Welcome to this video. Today we will be going to discuss about Kubernetes. We'll get into the details of pods, deployments and replica sets. So we will look into the deeper, into integrate details about these core concepts. We are working on three fundamental components, which is the backbone of Kubernetes orchestration. This enables us to manage and scale our application in a containerized environment efficiently. So let's look into this Kubernetes, a powerful platform for automating your application's deployment, scaling, and management. And using this concepts, you can run complex microservices architectures, and even you can run traditional monolithic applications or anything in between. If you have an application which is partially monolith and microservices. So in previous videos, we saw basics of Kubernetes and its key components like cluster, nodes, and control panel. Now in this video, we will build upon the foundation which we covered earlier, and we'll explore in a hands-on manner the essential concepts to understand how Kubernetes handles your deployment and scaling. We'll also learn how to use labels and selectors, and we'll also learn how to utilize kubectl, a command line tool for managing Kubernetes. So let's start. I have started GitHub code space. This is with 4-core CPU, and I will be running all my Kubernetes deployments using Minikube. So I have Minikube is by default installed in code space. So what I have to do is I have to run minikube start command. So as you can see in this screen, I have already started my minikube servers also. So I have the cluster configured already. Now first step is I will create a pod. So let me demonstrate the concept of pods. Pods are the group of containers, and these containers will share resources like network address. They have the same IP address. They can communicate with each other. Containers in the pod can communicate directly with each other without any external interface requirements. So let's create what I go here, I create a new file. I'll call it the pod manifest file. And how do I create it is just by going into my Visual Studio Code interface, which you see on my browser, and I will create this file. This file will be named as this is pod manifest, or let's name it nginx.pod.yaml. So all these files will be YAML files. So once we have this pod.nginx YAML created, now here I will be demonstrating what are the various tags I will be using. So this by default the API version v1, this is required for Kubernetes. Then I'll say the kind is pod. Then there is some metadata which I can add here. For example, name, and this is name I will give nginx pod, because I'll be running a nginx image. And then I will have here other details like what is the containers, and here I'll give the name of the container as nginx, and I will use an image. So the image which I'll be using is, as I said, nginx latest image. So this is from the Docker registry. So I go to Docker Hub. Docker Hub is your default registry, and in the Docker Hub the nginx image, this is the image which I'll be using. This is the nginx image. You see here, this is official build for nginx. Nginx is A proxy server is an open source reverse proxy server. It could be used to serve web pages as well. So this is what we will be building. So I got this and you have to open some ports. So I'll say them ports and then I say container port 80. Now I got this nginx pod file ready. Now to run this pod, I will run kubectl, then I'll say apply -f is for the file. I'll specify the file and then I say nginx pod .yaml. So I'm running this command. So let me print the current working directory. This is my current working directory. It is complaining that file is not there. Okay, so the file naming, I did a typo while naming. So let me rename and fix this. So it's nginx-pod.yaml. So now let me run again the kubectl command. So you have to say kubectl, then you have to put apply, only one space required, -f flag for specifying the file of the pod, and then I run this command. Okay, so it says some syntax errors there. Let's see. It says that on line number 9, which is the ports, I could not find expected colon. Okay, let me check here. Parsing error converting YAML to JSON. YAML line 8 could not find expected colon. Okay, got it. So here I missed this colon in line 8 actually. So here image nginx latest. So now this is fixed. Let me try again the third time, and now the pod has been created. But how can I check this? I can run again kubectl, then say get pods, and you see here nginx pod, it is running and it is ready as well. Nice, this nice. Now next thing, I can yeah, you may see here first the status should be container running created, container creating, then it could be running. Running is the state. It says 1 by 1 is ready. So this is good. So far our result is what we expected. Now there is another important command which is kubectl get describe get describe pod, then I say nginx pod. This will describe the pod and it will show all the properties. So here you can see that these are the properties. So you can use this for debugging purpose. So you see here there is a container ID, then you have the image, then you have image ID, you have the port 80 TCP IP, it's running. So it's time when it started, so it's state which is ready, and any restart if done, then these are the states. So you may see initialized, ready, containers ready, pod scheduled. All these status are true. Then you have other details and various other events which has happened. So this is the entire logs as well as the description about the pod. So it's quite a comprehensive description. Now let's access this nginx server. So we'll say kubectl, we'll give some command again, kubectl. I will have to do some port forwarding. I will say pod nginx pod, because 8080 is what I'll forward the port 82. I'll run this. So it has started port forwarding, and I see these two message, and when I open it in the browser, I should see now Nginx running. So here you see Nginx is running successfully, and this is running using Kubernetes. So this is how I was able to create a pod with Nginx. So now this is successfully running, and next step is, if we are done with this, what we can do is we can create another, we can clean up these pods also, right? So let's stop this also. So what can I do is I can say kubectl delete pod nginx pod. So this is if you are done with your application, you want to stop up and clean up, then this is the command. So you got the pod deleted. So here you would see now there is no pods available, right? And if I go here and if I refresh, now the pod is deleted. Now I don't see anything running here. So these are all commands related to pod. So this is what is about pod manifest and how to run pods, which is a fundamental unit or a smallest unit in a container for deployment. Looks good so far. So next, now we'll move on to the other part, which is deployment. So what is a deployment? And even before deployment, let's also consider replica set, because now our pod is running, but there is only one container here, and if this crashes, so then there is availability concern. So how can I ensure availability for Nginx is what we will be discussing next, right? But some details I will give, that V1 indicates the version 1 for Kubernetes, and this is the API version for Kubernetes, which will be defined. So basically we will have a API server. kubectl is the client which will connect to the Kubernetes control plane, where we have the API version V1 for Kubernetes. Now next thing is kind. Kind is the pod. We will see other kinds of the deployment. What I can say, these are the resource which we'll be creating. So pod is the type of the resource. It is set here pod resource type. Then there is metadata. Metadata is basically here the name of the pod or resource. And then you have a spec. Spec means specifications. It specifies the desired state of your Kubernetes. So you should understand that Kubernetes uses declarative language. So basically YAML file, this you see is a domain specific language here for Kubernetes, and it's a declarative language. You just declare what you need. You provide your spec, and Kubernetes environment will ensure that whatever is mentioned in the spec is honored, and it will create containers as per the spec. So here we have container with the name Nginx, and the image also we provided, which is the Docker image. I can change the version with colon or change the image here. And then we specified the ports. Ports are optional. Some containers may not need it, but here, since our Nginx is a web proxy and it has to expose a port which is the default HTTP port, and port 80 is what we are exposing, and we forwarded this port also so that we can access it in our container. So this is how you will be executing the pod manifest. And for executing the pod manifest, we ran the command kubectl apply -f and the name of the manifest. So this is just a recap of all the concepts we covered around pod. So next, move on to replica set. Replica set is another concept in Kubernetes. It is again helping us to maintain here number of pods. So basically replica set is number of pods, and we always have to manage set of pods because application will contain multiple pods, and replica set ensures that your pods are always running. If any of the replica fails or is deleted, it will be automatically replaced by the replica set controller, which is a Kubernetes process. So now let's create a replica set. So to create a replica set, again I'll create a manifest file. This time I'll call it nginx replica set.yaml. So my name, I'm just checking, this time no typo. So I see that new file has been created. Now again, same details. I'll put API version. I'll say v1 kind. This is same structure format, but I say here replica set because we want to create a resource of replica set. Then metadata. Metadata is name, and we'll say this is we'll use the same nginx container, since now you are familiar. We created the pod earlier. Now I'll specify spec. So after metadata we put spec. Then we have replicas, which is here 3. Then selector. Then here I will say match labels, and then app and nginx. So these are no match labels. So this is something new. A selector has been created here. I'll discuss this just after a few minutes. I have to provide a template here for the replica, and the template will again have a metadata, and then a metadata will have labels, and then I have here app and nginx. So this is space is very important in YAML. So I put app colon then space. Then this is label. Label is kind of metadata, but next thing which is important is spec, and spec will say what containers I have, and then I will say name nginx, and then I give image nginx latest, and ensure no typos. Then again this spec is same as the spec of our pod. So basically same thing we can copy here. Spec of the replica is almost the same as the spec of our pod. But what is important here is that we have defined the replicas, and replicas in this case is 3. So we will get 3 containers or 3 pods of nginx which will be running. So this will ensure high availability. If one goes down, the 3 pods will be created. It will ensure availability as well. So we will next look into how to run it. But just give me 1 minute. I will need to do some check, and then I'll get back in less than a minute. Basically I'm checking if the recording is going well. So just hold on for a minute. Okay, now let me see if the audio is fine, because I noticed that okay, my audio was not recording. Hello. Yes, so now audio should be there. Let me just check. Working directory. This is my current working directory. It is yeah, no issue. It was working well. Yes. So now audio should be there. Great, great. Okay. So just was ensuring that I had all the setup working properly, because sometimes my recording gets lost. So seeing there is no glitch and this session is available for everyone's benefit, because this is very important topics which we are covering. Pay attention. So replica set is a very important concept. Just no ignore for the time being for about selectors and labels. I'll cover them in next few minutes. So now we got the manifest created for our replica set, and these are the content. Again, same command in order to run the replica set. Now we don't have anything running here, because if I say kubectl command and say get pods, there is no resource found in default namespace, because we deleted what all we created. So pod we created earlier, we deleted it. Now we will restart it. We create again. So we will now this time use the same command. Let me type it rather than trying to copy it from my previous yes history, but yes, you can get it from history also. So minus, so I apply minus f, and here in nginx, then I have here replica set dot yaml. I run this. I see, okay, mapping not found, replica set namespace. Okay, let me see what is the problem here. No match for the kind replica set. Okay, so is there replica set? So it's saying no match found for this replica set. Okay, is this the error? Resource mapping not found for no match find for the kind in version v1. So let me just see this issue. Okay, okay, got it. So there is a small correction which I have to do here. The API version. So actually there is a version mismatch. All the replica set is defined. The versions should be apps.v1. So yes, you see, when you do practical, there is new things which you learn. So for pod, there was no problem. We had the v1, and but here for replica set, this manifest, it should contain apps/v1. Now let's see what happens if I run the command again after making these changes. Okay, so now I have changed it, and I run it. Okay, okay. So there is spec, and yeah, let me fix this also, because here indentation is very important. So actually this spec is for the template, so it should be with the metadata, right? Yes. Now the hierarchy is, let me tell you, share again. At the root level you have API version, kind, metadata. Then metadata is the name for the replica set. Then at the root level again, the spec for the replica set, we say that we have 3 replicas. We also define the selector for the replicas. Here we give the match label, and match label is the app nginx. And then we define the template within for the spec, and in the template we have metadata and then labels. Then we define app nginx is the label. Then after this we have the spec. Then spec is, we say that we want containers with name nginx, and we want the image which is nginx latest image. Then we say ports, and we want the port which is the container port 80 to be available. Now I run, and now it is created successfully. So now we resolved all the errors, and the replica sets are created. So I also explained you in depth about the pod manifest file, and command is run successfully. So we will see whether the replica set, will double check whether replica set has been created successfully and is ready. So we give the command kubectl get rs for replica set, and you see here we wanted 3 containers, and currently 3 are there and all are in ready state. So this is again, our nginx is ready, it's running in replica set. Now so we see replica set is nothing but the set of pods, right? Correct. So some important things, because we gave this command. So you see here, this is the output, what you get. Yes. Then when we check status, so we get this output. Again, this is very important. I'm just noting down so that I will be sharing you when steps for executing all these commands. You will find what output to be expected in the step-by-step guide, which I will also be sharing to you. All the links and related resources will be provided in the description for this particular video. So now our replica set is running with 3 containers. We can scale it also. So now here, if you want, if you want to scale it up and down, that is also possible. So for example, if I want, instead of 3 containers, 5 containers, so I can say scale replica set, then I say nginx and replica set, then I can say replicas equal to 5. So this is the command which I will be giving: kubectl scale replica set nginx replica set. This is the name of the replica set, because yes, this is, see here, the name of the replica set is what I gave here. So I say scale replicas and make the replicas 5. So I do that, right? So what will happen here now, if I run the command get replica set, you see here again, I will get this replica set changed to 5, right? So this is good way to kind of scale your application. So very easily I can scale my application. Again, same commands will also work. Say for example, if I want the replica set to be so let's description details about the replica set. So I can say kubectl describe replica set, and then I gave the name of the replica set, which is very simple. I gave nginx hyphen replica set. So when I do this, I see everything as which are details of replica set. So this is the replica set. It has now currently 5 containers, pods are there for this particular replica set, and these are the various pods which are running here. Right? So you can scale, you can delete the replica set altogether. So so now to access any pod, what I can do is I can see here, these are the pod names. And if I want to access any pod, so I can use the same command which we used earlier for our pod. For example, I can say this command port forward, right? So I can say kubectl port forward, and then I have to give the name of the pod which I have to forward, and also the specify the ports which I am forwarding. So here last time I said pod slash nginx pod, but this time I will have to give the name of the pod, which is nginx replica set, and I chose one pod out of all the 5 which is running, and I will say 8080 whatever is exposed 80, I run this. So the port forwarding has started. I can open it in the browser, and you see here the nginx is running. So you can verify each of the pod whether it's running or not, and each of them will be serving nginx, which is this container which we chose. And once you are done with all this, what you can do again is you can delete the replicas. So let me delete the replicas. So kubectl delete, and I will say replica set here. So the command to delete a replica set is delete rs for replica set, and then the name of a replica set, which is nginx replica set. So here we will see this is deleted. So all the pods will be deleted, and yes, whatever is there in the replica set is also deleted. So yes, after giving this command, if I say kubectl get replica set, there's no resource. If I say kubectl get pods, again no resources found in the, because we have deleted, so there's no resource found in the default namespace, which is expected. Now let's look into another concept, which is Kubernetes deployments. And then okay, but before that I can I can talk about the selectors and labels, because that is also something very important, and we will talk about deployments after labels and selectors. So labels and selectors, what we are using here. This is selector, and then there is something called labels. So this is a foundation concept, and it's a very important concept for managing resources within Kubernetes. And this provides very good flexibility, because remembering the name of the pods are always sometimes tricky, right? Labels are nothing but it's a key value pair. You can use any key value pair, and you describe the label for any object, which could be a pod or a service, or it could be some deployments also. So we'll cover about service, etc. Later. So we can expose a pod as a service also. And then these labels are applied to object during the creation time, and they can also be modified using various commands. So to demonstrate labels then can be there could be selector also. Match label is a selector here. So so that's very important thing here. So if I describe you the pod manifest, so pod manifest, I said API version, this is apps.v1. We saw this. The kind is replica set, and then this is the resource type basically. Then you have the metadata has the name. Metadata also have the specification. The specification says that we want 3 replicas, and then we want a selector, match label selector, and what we want is the selector dictates how the replica set identifies the pods. So we will say the pods will be labeled as nginx, and then we put a template defines how the pods will look like. So template has a metadata, again it has a label. We gave the label as app nginx. So the pods will be created, and app is equal to nginx is what the label which we have defined. Then we have in the spec, so metadata, and again we have the specification. Specification has containers, and containers has a name which is nginx, and image which is nginx latest, and we are exposing port 80. So this is about the pod manifest. So here you see, here we are using labels and app, so that labels and selectors, so that we can kind of select and easily work with various resources. So this is nothing great about this. This is simple concept. We saw how to scale, and basically it provides precise control, and other stuff like load balancing, service discovery, and organizing your resources is enabled by the use of selectors and labels. Let's try some commands, right? So these are commands which I will try, but yes, we'll look into the commands of using labels and selectors later. But let's do another concept, which is deployment. So for creating a deployment is another entity. Deployment is basically again a declarating way of creating and updating pods. Deployments can contain multiple replica set, and it helps you define a desired state. And this helps deployments helps to ensure high availability, fault tolerance, and load balancing for your application, right? Deployment will allow you to update and roll back, apply update and rollbacks to your containers or pods. It also allows you to track your version and history of the deployments. And definitely, you can scale the deployment by giving instructions to replica set to create or delete additional pods as necessary based on your scaling requirement for your application. So to create a deployment, we will have to create a YAML file again, which is nginx. We'll name it like nginx deployment.yaml. You can name it whatever you want, but I'm following this convention that I am prefixing with the name of the deployment and then followed by the resource type. So the name becomes nginx-deployment.yaml. Now, what will be the content? So here, first two lines is we have the API version, we have the kind, which is deployment. Then we need many things are similar to what we had in the replica set. We have the metadata, which is the name and which is spec. Then we have replicas. We will create 3 replicas, and then we will create also we will put selector for the replica, because replica for what? I would say selector. Selector is match the label, and if you see the label app.nginx, then this is the template which you have to pick and create a replica of, right? So this is selector I defined for my deployment, and then I create the template for creating my pods. And again, the template will have metadata here app.nginx, and then I will specify what to do in this deployment. So I will choose here and this time, rather than the latest version, I would say I want containers, I want container nginx, and then I choose the version of nginx which I want to use. So this is in your Docker Hub, you can check. So let me go to Docker Hub. So this is the nginx container which I will be using. This is the nginx image which I will be using to create my Kubernetes pods. So here you see there are various versions. So there's version 1.25, 1.24, right? So there are so many versions available. So let's use something which is recently 1.24 looks good. So let's use 1.24. So here let's say 1.24 is my current version, and we will then update it to maybe 1.25. So that could be one way. So we can specify all 3 versions. So this is semantic versioning. You have the major version and minor version and the update. So we will put major version 1, subversion or minor version 24.0, zeroth update of version 24, patch update for version 24. So this is how we will use the version rather than latest. If I put latest, then I will get something latest which is currently 1.25.3 at this particular time of recording this video. Now I specified everything in the deployment, and I can save, and then I can create the new deployment. Now to create a new deployment, the command which I will be running is I will be running command, which is again our very favorite command. By now you would have got by heart this command. Whenever you have to run any deployment on Kubernetes, whenever you have to create any resources in Kubernetes, you have to give kubectl apply -f nginx deployment .yaml. This is the command which we'll be giving so that the resources can be created as per the deployment description in the YAML file. And created the deployment instantly. See, it's so fast. And now we can verify this. So to verify it, I will give this command kubectl get deployments, because I need to see if there are 3 replicas. Yes, I see that there are 3 replicas. This is great. All 3 replicas are ready. You may see that some are not ready initially, and then after some time you can again give this command and you will see the ready state. But yes, this happens fast. You may see all ready as well. So now we'll demonstrate use of kubectl get pods command, right? So when I do this command, I see all the pods, right? Now there could be many pods which could be running. Labels could be used here. So if I have to filter some of my pods, I can do that as well, right? So I'll show you how to apply some labels in any of the commands. So when you give kubectl command, you can give some label selector also. So here I could have given again kubectl, then I say get pods, and then I can say label, apply label, and the label could be app nginx. So this is another way of giving labels, right? Same result because all my pods are labeled with nginx. But yes, if I give some other label, for example, if I would have been running say Tomcat as well, and assume I have given some containers label of Tomcat, then this will list all the resources which have label app equal to Tomcat. But I don't have that resource, so no, nothing is showing up here. So this is the way you can kind of filter your resources while applying any commands or while applying any configuration. So now we got 3 pods which is running. So deployments are basically used for doing rolling updates. So now let's do rolling update. So what I will do is I will change this version to 1.25, right? Let's see, because that could be very good thing. And get pods, and so other command which we can use is describe command also. So let me run the describe command also quickly so that we can see the description of the deployment as we saw for replica set, right? So for replica set we ran the command. We did scaling also, but before that you would remember that we would have run the describe command, right? So to describe a resource, what you have to do is you have to run something like kubectl describe, I would say describe here in this case deployment, and my name of the deployment is nginx -deployment, right? So when I do this, you see here, this is what is the details of the deployment. Deployment name is nginx deployment, then when it was created, the timestamp for creation, then what is the version, revision, selector, replicas, rolling update is the strategy type, and then I have other details also about port, and then I have various other details. So there could be some conditions which could be applied. Normal scaling replica scaled up to Nginx deployment to 3. So all these details are events. Every event is also registered here. So now after running this describe command, let's apply this update, because now we have updated the version to 1.25, because what we have is Nginx 1.24. But with the help of rolling update strategy. By rolling update strategy, we mean that not all the instances will be updated together. They will be done one by one. So availability of the pods will not be affected. User will be able to see always the applications or services running. So we change this version. So earlier it was 1.24. We will now change it to 1.25, right? Because these are the latest and the previous ones as per today's date when I'm recording this video. So let me now apply the updates. So the command to apply updates is same again. I have to say nginx apply -f nginx deployment.yaml. So basically to update my containers, what I have to do is I have to update the deployment file manifest, manifest file or the configuration file, and just reapply the changes. So now again it says deployment configured. So basically what has happened here, it would have updated the Nginx, right? So now if I go and again ask for describe, or let me say, yeah, describe would be best way to see what has happened to my deployment. So here you see now when I give the describe command, it showed that my Nginx deployment is there with 3 instances. Now the revision number 2 is there. Rolling update, always 25% max unavailable, right? So this is some rolling update strategy. Then these are by default applied. Now you see here the version has been updated. And then I see the logs of the events. So old replica set is all closed and new replica set is now created. So here first is scaled up replica set to 3. This was happened earlier only. Then is scaled up replica set. Okay, so what it does is it created a new deployment set, and then so you see here it is kind of creating new instances and then scaling down one by one, so that by the end you get all the containers pods replaced by the newer version of the pods. And it has done after few seconds, right? So it's not done immediately. It has done every 2-3 seconds it is updating and creating new instances. So there will be no impact on the availability of your application if it is a stateless application. So this is about rolling update. Assume we didn't like this update, and this update had some failures. There were some bugs or errors available after we did this update. We felt that yes, probably previous version is what we need. We want to roll back to the previous version. So what we can do is we can put some command kubectl rollout undo deployment, and then we are nginx deployment. So this is the command which will run. Now it will roll back all the new changes which has been applied, right? So our version should again be back to the previous version. So let's again give this command, describe deployment and nginx deployment. And now you see here there is more activity. So yes, so here our latest command is this one. You see here the version is 1.24. So all the changes have been rolled back. And yeah, here these are the new activities. So again, it does the rollback also one by one, where all the containers were replaced and the previous version 1.24 is restored back. So this is so simple here that you can update any changes and then you can take it back, your changes, if you didn't find it useful. Now assume everything is fine, but we want to scale this deployment. So like we scaled the replicas, we can scale deployment as well. And when I say nginx is my deployment, so I give scale deployment, then the name, and then I say replicas equal to 5. So my deployment is now scaled. And to verify this, I can say kubectl get deployments, and I should see 5 replicas running and available. Right? So this is about the deployment. And then finally, last thing which I'll be doing is I'll be deleting this deployment. So last command which I will run is kubectl delete deployment, and then I say nginx deployment. Right, so this should delete the deployment. And if I say give the command kubectl get deployments, there is no resources found. I have cleaned up everything which I created. So you see here we covered the concepts pods, replica set and deployment. And we also covered about how to scale up and down a replica set. We also covered how to scale up and down a deployment, and more importantly how to update the pods of a replica set and deployment. So we saw how to update the pods of a deployment using rolling update strategy. We also see how to undo or roll back your updates so that you can restore to the previous stable version. And we also learned about various deployment configuration files. We also learned about the pod details, pod configuration, replica set configuration, deployment configuration. We learned about selectors and labels. So that's all for today. If you have any questions, please feel free to ask in the comments. And if you have any further suggestions or topics which you want to learn from me, also share your feedback suggestions in the comments. Also, for more such sessions, keep watching this channel. I would suggest subscribe to the channel, and if you find this video useful, feel free to also, I will encourage you to like this video so that this video reaches more audience. And I also feel good to see your likes, and I'll keep sharing and creating more such videos. Thank you for today.